In this video, we are studying about simple harmonic motion. Let's take the example of a simple pendulum. This is simple pendulum, and its mass is m. When a force F is applied towards the left side, it will move towards the extreme position, which will be somewhere here. And when it reaches at the extreme position, it comes to rest, and due to restoring force which acts towards the mean position, the pendulum moves back, and it shoots in other direction. So continuously pendulum keeps moving to and fro about this mean position. Let us derive the equation of time period of simple pendulum. So to do that, we have to consider the force acting on the simple pendulum. At this point, the force acting on the simple pendulum is downward force, which is mg, or the weight of pendulum, and the tension T. When the pendulum is at some distance x from its mean position, it subtends an angle theta. Right? Now, this force mg can be divided into two components using the vectors. So one component will be like this, which balances actually tension, and the other component will be towards the mean position. So these are the two components. Now this force which is acting towards the mean position F is equal to mg sine theta. How you find this relation? By using the parallelogram method of vector addition. Since these two are the vertical lines and this line is moving straight, so this angle must be also theta, because this angle is theta, and here other force is mg cos theta. Now since we are interested in restoring force, so what we can do here, we can write F is equal to mg sine theta. From Newton's second law, F is equal to ma, so ma is equal to mg sine theta. Now we can cancel it, and we'll get a relation A is equal to g sine theta. For very small angles, sine theta is approximately equal to theta. In that case, we can write theta is equal to x by L using this diagram. So x is the displacement and L is the length of pendulum from this mean position of pendulum. So now our equation, this equation, it looks something like this: A is equal to g x by L. Now we know A is equal here. First of all, we can compare it with simple harmonic motion, which is A is equal to omega square x, and since this acceleration is negative to the displacement, we can put a minus sign, and same thing we can do here also, because restoring force is always towards the mean position. So we can put minus sign here, minus sign. Now comparing these two relations, this one and 2, what we will get is, we will get omega square is equal to g by L, and we know omega is equal to 2 pi by t. So putting it and rearranging the equation, we will get t is equal to 2 pi under root L by g.